What is a decision tree? A decision tree is a supervised learning model used for classification and regression tasks. It splits data into subsets based on feature conditions, creating a tree-like structure where decisions lead to outcomes, leaf nodes. How does a decision tree work? A decision tree splits data at each node using a condition G. Age in 30. It chooses the best split by maximizing homogeneity, classification, or minimizing variance regression. The process continues recursively until a stopping criterion is met. What are some common algorithms used to build decision trees? Can ID3 iterate dichotomize a 3-case tree? Splits using information gain. C45 improves on ID3 by handling continuous variables and using gain ratio. Card classification and regression trees splits using Gini impurity or mean squared error. What are the key components of a decision tree? Root noding represents the entire dataset and the first split. Internal nodes represent decision points. Leaf nodes represent predictions, class labels, or values. Branches represent outcomes of decisions. What is entropy in a decision tree? Entropy measures the impurity or randomness in the dataset. It helps identify how well a feature can split the data. Lower entropy indicates higher purity, meaning the data predominantly belongs to one class. What is information gain in a decision tree? Information gain is the reduction in entropy after splitting data based on a feature. A higher information gain means the split produces more homogeneous subsets. What is Gini impurity and how is it used in decision trees? A Gini impurity measures the likelihood of incorrect classification if a sample is randomly chosen. It ranges from 0.2 to 0.5, maximum impurity in binary classification, and is used in card to select splits. How do decision trees handle categorical and continuous data? Categorical data split based on specific values or combinations. Continuous data create thresholds ZG, age and 30 to divide data into intervals. How do you prevent overfitting in decision trees? Overfitting can be mitigated by G limiting tree depth or the minimum samples per leaf, pruning unnecessary branches, using ensemble methods like random forest. What is pruning in a decision tree? Pruning reduces the complexity of a tree by removing splits that contribute little to model performance. Pre-pruning stops tree growth early using constraints. Post-pruning trims the tree after it has been fully built. What are the advantages of decision trees? Easy to understand and interpret, handles both numerical and categorical data, requires minimal data preprocessing, non-parametric and robust to outliers. What are the limitations of decision trees? Prone to overfitting with deep trees, sensitive to small data changes leading to instability, less effective on high dimensional or imbalanced datasets. How do you evaluate the performance of a decision tree? For classification, use metrics like accuracy, precision, recall F1 score and ROC AUC. For regression, use like mean squared error MSEC, mean absolute error MAEC, and R squared. How do decision trees handle missing values? Imputation replaces missing values with mean, median, or mode. Surrogate splits use alternative features to mimic the primary split. What is that? What is the difference between a decision tree and random forest? A decision tree is a single model prone to overfitting, while random forest combines multiple trees built on random subsets of data and features, improving accuracy and reducing overfitting. What is the significance of tree depth in a decision tree? Tree depth determines model complexity. A shallow tree may underfit while a very deep tree may overfit. Controlling depth balances bias and variance. What is the role of feature importance in a decision tree? Feature importance quantifies the contribution of each feature to the tree splits. It helps interpret the model and identify the most relevant features. So, what is a regression tree and how is it different from a classification tree? Spaces that can. A regression tree predicts continuous values by minimizing variance, while a classification tree predicts discrete classes by maximizing purity. What are ensemble methods in decision trees? Ensemble methods combine multiple trees to improve performance. Random forestic uses bagging bootstrap aggregation. Gradient boosting sequentially builds trees to correct prior errors. What is thus the role of cross-validation in decision tree modeling? A cross-validation ensures the model generalizes well by evaluating its performance on multiple subsets of the dataset, helping to avoid overfitting. What is the difference between entropy and Gini impurity? Entropic measures randomness in the dataset. Gini impurity measures the likelihood of incorrect classification. Both are used to evaluate split quality but differ in calculation and interpretation. How do you decide that the best split in a decision tree? The best split is chosen by maximizing information gain classification or minimizing variance regression. The splitting criterion depends on the algorithm, Gini entropy. Hugging face space at Ken. How do you determine the stopping criteria for building a decision tree? Stopping criteria include maximum depth, minimum samples per leaf, or minimum information gain. These constraints prevent overfitting and reduce model complexity. How do decision trees handle class imbalance? Decision trees can struggle with class imbalance. Techniques like resampling, class weights, or ensemble methods, random forest can address this issue. Can decision trees handle large datasets efficiently? How? Decision trees handle large datasets but may be computationally intensive. Techniques like limiting depth using ensemble methods or parallel processing improve efficiency. How does the choice of the splitting criterion Z? Both Gini and entropy often yield similar results. Gini is computationally faster, while entropy may provide more nuanced splits in certain cases. Why spaces that can? What is the difference between pre-pruning and post-pruning in decision trees? Pre-pruning stops growth early based on constraints like depth. Post-pruning trims branches after fully growing the tree. How does a decision tree handle unseen data during inference? On hugging face space that can, unseen data is passed down the tree based on the conditions at each node until it reaches a leaf where the prediction is made. Here's that can. What happens if a decision tree is trained on highly imbalanced data? The tree may become biased towards the majority class. Resampling, cost-sensitive learning, or ensemble methods can mitigate this. Application. How does the minimum sample size for a split impact the decision tree? Increasing phase spaces in the minimum sample size prevents overfitting by ensuring splits occur only when there is sufficient data. Why are decision trees considered a non-parametric algorithm? spaces that can. Decision trees make no assumptions about the data distribution and adapt to the structure of the dataset. How do you evaluate feature importance in a decision tree? Spaces that can. Feature importance is computed based on the total reduction in impurity, Gini, or entropy attributed to each feature across all splits. Now, what is the difference between decision trees and boosting algorithms like XGBoost? The decision trees are standalone models, while boosting algorithms like XGBoost build trees sequentially to minimize errors from previous trees. How does a decision tree handle redundant features? Redundant features may not harm performance but can increase tree complexity. Feature selection or dimensionality reduction can address this. In what scenarios would you not use a decision tree? Why? Avoid using decision trees when the dataset is very large, inefficiency, highly imbalanced, or in most complex relationships best captured by ensemble or non-linear models.